Welcome everyone to SRR Olympiad and IIT Academy. So I have started a new series based on my own material and own syllabus, and the name I have given for the syllabus is TAKSH. Okay, so based on that, we will be discussing every day about the topics and everything through digitalized way. Okay, so to start off, we are starting with the basics of science, that is called as matter. Okay, as you can see on the screen, it clearly says about matter, everything around us, properties, states, and also the changes. It belongs to the system of TAKSH. Okay, if we go deeper and further, actually what is matter and how the matter behaves. Okay, the key definition of matter is anything that has mass and occupies space is called as matter. For example, we have a lot of things in our surroundings, like the day-to-day things, the water bottles, or even anything around you. Okay, everything is called as matter. The key characteristics of matters include mass, space, and also tiny particles. Can be felt, seen, or detected. Can neither be created nor destroyed. Okay. Examples of matters include air, water, wood, iron, sand, salt, plastic, glass, human body. Even we ourselves, the humans, we are also a part of matter. Okay. So as we go here, which is not a matter: light, heat, sound, electricity, shadow, love, feelings, time. So whatever the things that are mentioned here, those are not considered as matter. Okay. So if we go to the next part, what are the states of matter? Actually, there are three states of matter. First one, it's solid. Second one, it's liquid. And third one, it's gas. Okay. When we come to solid, solid is a kind of material that has fixed shape and volume. Particles are tightly packed, and also very strong intermolecular forces will be there in between the in between the molecules, and also particles only vibrate in one place. Okay. Example: ice, iron, wood, rock, and sand. That's why we, every time we see at a rock, it is very hard in nature. Okay. When we go to the second part, that is liquid, it has fixed volume, no fixed shape, and also particles close but can move. Moderate intermolecular forces take shape of container. Example: water, mercury, milk, and petrol. See here, there is a specific thing called as mercury. Mercury is the only metal which exists in the liquid form in the room temperature. Okay, so a liquid has a fixed volume but no fixed shape. It can take the shape of any container it goes into. Okay, so the next is gas. No fixed shape or volume. Okay, gas doesn't have anything. Particles are far apart, move freely. Very weak intermolecular forces fills entire container. Example: air, steam, oxygen, CO2. So whatever this gas is there, these gas type of materials are very what you say, we need to measure them using a experimental basis, but not in a simpler way. Okay, like for example, if you want to measure a gas, how can you measure the gas? You need to fill up a balloon, and if you take that balloon and place it at a container, then you can see how the mass or how the weight is calculated when we take up the gas. Okay, so the next is the fourth state of matter, that is plasma. Okay, nowadays there is another state of matter that is also called as plasma. Plasma is a superheated ionized gas in which electrons are stripped from their atoms, creating a mixture of free electrons and ions. Okay, what do you mean by this? See, plasma is like a superheated state, like where the most heated part of the whole place or a whole part of an object is called as a plasma. Example, okay, you can take electricity as a form of plasma. Like, okay, so key properties: extremely high temperatures, thousands to million degrees Celsius, electrically conductive, response to magnetic fields, most abundant state of matter in the visible universe, does not have fixed shape or volume, and also particles are ions and free electrons. Particles which are involved in the plasma are simply electrons themselves. Okay, electrons which we will see in further are those electrons which we see in an atom are existed in plasma. Okay, And examples where we can see plasma, the sun and the stars, lightning, neon signs, aurora boreals, and also fluorescent lamps. Okay, what are these things? Especially, I think you know first two things, the lightning and the sun and stars. What about the neon signs? Neon signs are casually when you go outside nowadays. The attractive lights or the attractive lighting, whatever you are facing here, okay, whatever you are facing in the outside, those billboards, okay, those are made up of neon signs where they get plasma. And also aurora borealis. So at the place of poles, north pole and south pole, sometimes in the night time you see a cheap colorful kind of waves, okay, those are called as aurora boreals. And also fluorescent lamps, mercury vapor plasma inside tube, okay, these can be seen in an experimental ways, okay. And next, particle nature of matter. Matter is particulate, particles are in motion, particles have spaces, particles attract each other, particles are extremely small. Diffusion, evidence of motion. So these all comes to the properties of a matter, okay. So matter has particles inside it, whatever the molecules, those are called as what particles, okay. So matter is particulate. All matter is made of tiny discrete particles called as atoms or ions that are too small to see with our naked eye. We cannot see the parts or else whatever inside a molecule with our naked eye. What is a naked eye? Our eye, okay. We cannot see it directly, we need a microscopic vision, okay. Particles are in motion. All particles possesses kinetic energy and are in constant random motion. Higher temperature is equals to faster motion. So when the temperature gets high, the motion becomes very fast, okay. Particles have spaces. There are empty spaces between particles. The amount of space depends on the state, smallest in solids, largest in gases. So whatever the space is there, means the gap between the molecules, it is a kind of property that we need to see. And also particles attract each other. Intermolecular forces hold particles together. Strength varies, strongest in solids, weakest in gases, moderate in liquids, okay. So that means whatever the particles are there, they hold an intermolecular force, which means a particle, the one particle attracts another particle. Imagine this round two things as particles inside a matter. These things always hold some kind of force, okay, that will attract or else either it will repel, okay. Next, particles are extremely small. A single drop of water contains about 1.67 into 10 to the power of 21 molecules, more than all the stars in the observable universe. So a single drop of water, what he is mentioning, contains about 1.67 into 10 to the power of 21 molecules, more than all the stars in the observable universe. That means a single drop of water, when you take a whole bottle of water and when you look at a drop of water, that single drop of water has these many amounts of molecules, okay, where we can where the entire universe is also smaller than these molecules. That means imagine the number of molecules inside a single water molecule, okay. Diffusion, evidence of motion. When a drop of ink is added to water, it spreads throughout over time. This is diffusion, proof that particles move. So what happens here is particles also have motion. When, for a best example for this is, if you see incense stick, we call it as agarbatti, okay, in many places. So that incense stick, when it gets burned, a heavy smoke comes out of it, yes or no? Yes. So through that smoke you can simply say that a particle is moving from one place to another place, yes or no? Yes. So that's how the particle's nature will be there. Next, classification of matter. Matter is classified into two types, pure substance and mixture, okay. The pure substance is further divided into element and compound, whereas mixture is divided into homogeneous and heterogeneous. These will be learned in future classes elaborately, so simply we can learn it as a base now. So pure substance, an element can be said as cannot be broken down, means it is a final stage in which we have researched till to the date, and those examples are oxygen, iron, and also silver, gold, hydrogen, mercury, everything, okay. And compounds are 2 plus elements chemically combined. Example, H2O, NaCl. H2O means the chemical formula of water and NaCl means our salt, okay. Mixtures are homogeneous and heterogeneous. Homogeneous mixtures are those mixtures which are in uniform composition, like how the amount of what you say, elements, okay, like here you see NaCl and H2O. Whatever the number of things that you take in a reaction, that will be discussed in further stages, okay. Simply remember that if you take 500 grams of rice, so compulsory you need to take 500 grams of curry, okay. That means in a reaction, whatever the things you are taking, those should be in a uniform kind of thing, like the amount of things you take should be equal, okay. That comes under homogeneous. When you go for heterogeneous, non-uniform composition, soil, salad, blood, see, when you see a salad like vegetable salad, you can see lot of vegetables, some might be heavy, leafy vegetables might be heavy, and also some kind of onions will be heavy, where most of the vegetables will be smaller, like that. And also soil, lot of iron fillings will be there, lot of pebbles will be there, rocks will be there, and everything will be composed of a non-uniform thing, okay. And next, properties of matter. What are the properties of matter? There are physical properties and also there are chemical properties. So physical properties include color, odor, taste, density, melting point, solubility, hardness and lustrous, malleability and ductility, electrical and thermal conductivity, states of matter. And when you come to chemical properties, flammability, reactivity with acids and bases, rusting, oxidation, decomposition, toxicity, heat of combustion, and electronegativity. So these all are properties of matter. We will be discussing about this detailedly in upcoming videos, okay. So when we go for the next one, it talks about changes in matter, how matter gets changed. Matter gets changed physically and also chemically, okay. So there is physical changes and also chemical changes. Physical changes means the state of matter will be changed completely, like how here solid to liquid, liquid to solid. Matter has how many states? 3 states: solid, liquid, and gas. I call it personally as sal medium, okay. Solid, and also air medium, and also liquid medium. So this is how you can remember it. Don't remember it as SGL, okay. Remember it as sal. It is a new medium. Remember that. For chemistry, sal is a medium where solids, air, and liquids will be there, okay. Under sal medium, there are these many things: melting, freezing, evaporation, condensation, sublimation, and dissolving, okay. When you go for chemical changes, burning, rusting, digestion, cooking, photosynthesis, and electrolysis. So these kind of things, whatever the things that are not irreversible, okay. Sometimes physical changes are also irreversible. For example, okay, comment down or else say whatever the general things you observe in your daily life where physical changes will happen but they cannot be reversed back, okay. I'm waiting for your answers. And also chemical changes, sir. What is a chemical change? Usually they are irreversible, but sometimes they are reversible too, okay. Only usually 19% of the chemical changes and physical changes are reversible or irreversible, vice versa. But here mostly chemical changes are irreversible, like burning, rusting, digestion, cooking, photosynthesis, electrolysis, okay. These general examples can be seen in our daily life also. So next thing, interconversion of states of matter. See how it is going on. So a solid will be converted into liquid on the process of reaching its melting point, okay. A solid gets converted into a liquid when it reaches its melting point, okay. A solid needs to be melt down, okay. A solid needs to be melt down so that it converts its structure, its physical state, into a liquid, sir. When liquid gets to the point of boiling point, okay, it gets converted into gas, sir, okay. This chart needs to be typically analyzed by yourselves, okay. Do analyze this chart typically. I'm moving away from the frame, okay. If you want, take a snap of that. And it detonates the points where every part can be converted into a state from state, okay. When melting happens, solid will be converted into liquid. When freezing happens, liquid will be converted into solid. When vaporization takes place, liquid will be converted into gas. When condensation takes place, gas will be converted into liquid. When sublimation takes place, solid will be converted into gas. When deposition takes place, gas will be converted into solid, okay. Right. So next, mixtures, types and separations. So types of mixtures. There are how many types of mixtures? We have 4 types of mixtures, and also separation techniques, like how we separate one element or many kinds of elements from many kinds of elements, okay. First we see about types of mixtures: homogeneous, heterogeneous, colloid, suspension. Okay, homogeneous, like already we have said, and also heterogeneous, already we have discussed. Colloid or else suspension. Okay, done. So what is a colloid? Milk, fog, gelatin, blood. What is a colloid type of mixture? This you will be learning in your higher grades, but just for your knowledge purpose I am saying, in our TAKSH syllabus, everything will be explained detailedly, covering from your 6th standard to even your 12th standard, so that a child who is going for early preparation of his dreams and also going into IIT and many further places, not only IIT, like science background, technical background, and anything, in our TAKSH syllabus, like in our curriculum, we discuss point to point, and also we discuss every concept in detail. Okay, do follow the videos. So colloid mixture, what is a colloid mixture? Example, milk. A milk can be converted into many type of things, right? And also a fog, the material which can be converted into many type of things upon reaction. Okay, that is called as colloid mixture. Like how milk can be converted into curd, milk can be converted into what you say, ghee, milk can be converted into butter, milk can be converted into what you say, lassi. Even you can make many kind of things. Okay, and also fog. What about fog, sir? So a cloudy kind of substance, like in winter seasons, a fog can be converted into water droplets. A fog can be condensed, and many things can happen. Gelatin, blood, everything will be in the same way. Suspension, chalk water or muddy river water. Okay, what is a suspension? Where if you see, there will be, we can discuss that later, but to your glimpse, suspension occurs when a sediment, solute, and everything will be there. Like how if you take a chalk piece and mix in a water, can you see the chalk powder dissolve in the water? No, the chalk powder won't get dissolved in the water. Wherever the chalk piece powder will be there, it will get down in the container, and it will remain in the downside of the container. Okay, that's what happens in the suspension. And when you go for separation techniques, so we have how many types? 6 kind of separation techniques: filtration, evaporation, distillation, chromatography, magnetic separation, centrifugation. We will be discussing about this in a separate video. Okay, next, about mass, volume, and density. So a matter has mass, a matter has volume, and a matter also has density, sir. What about mass? So the amount of matter in an object remains constant everywhere, even on moon. Means the number of molecules inside an object remains same wherever you go. But when it comes to volume, sir, the amount of space occupied by an object measured by displacement, Archimedes principle. Okay, this can sometimes change, but this can sometimes not change. Okay, it will be based on the space that molecules occupy. Okay, it stays with the object's behavior. Okay, molecular behavior. And density, sir, mass per unit volume determines if an object sinks or floats in a fluid. So to remember density, I simply say that the amount of air present inside an object. Okay, remember in that way. So mass per unit volume determines if an object sinks or floats in a fluid. If the air is more inside an object, what happens? The object floats. Okay, if the air is less, the whole molecules are present in an object, the object will sink. Okay, remember in this way. So to understand density, remember in a opposite way. If density is more, air pressure or whatever the air present inside an object will be very less. Okay, if the density is less, then air present inside the object is more. Okay, remember in that way. Next, diffusion and Brownian motion. Brownian motion you will be getting in futuristic, like how means not in a futuristic, in your very higher classes. Okay, we will discuss that later. But about diffusion, sir, already I have discussed about incense stick, how the molecules go from one place to another place, like from higher concentration to lower concentration. Okay, remember in that way. Examples are perfume spreading in a room, smell of food cooking, food coloring in water, and smell of a flower. Okay, and next, laws of matter. These are very important, and take a screenshot of this if possible. Yeah, take a screenshot of this. So with each law we will be discussing later. Like remember, in future videos we will be discussing about that. This is just a glimpse. Okay, so first one is law of conservation of matter, law of definite proportions, Next comes law of multiple proportions. Next comes law of conservation of energy. Okay, this will be very famous. Like the Albert Einstein, he gave energy formula which is equals to mc square. Okay, and next, matter in everyday life, like where you see the matter, wherever it is possible you can see the matter. Just go through this structure and everything you can understand. Okay, where gas will be there, where liquid will be there, where solid will be there, plasma is used, food, complex matter, and also alloys, mixtures. Okay, everything will go in deep in further classes. Okay, just have a glimpse of that. So to summarize our class, there are 6 major key points. Okay, first one, matter is anything with mass and volume. It is made of tiny, constantly moving particles with spaces between them. And also, matter exists in 4 states: solid, liquid, gas, and plasma. Each has distinct particle arrangement and properties. Matter can be classified as pure substance or mixture. Physical changes doesn't alter chemical composition. Chemical changes form new substances. States interconvert via heating or cooling. There are how many states, there are how many properties like melting, freezing, vaporization, condensation, sublimation, and deposition. So these are all the forms, or these are all the things, like the way in which matter can be converted from one state to another state. And also law of conservation, matter cannot be created nor destroyed. Total mass is always conserved in any reaction. So this is the ultimate law which we need to remember, where matter can neither be created nor destroyed. So this is how the classes will be taking place in our TAKSH curriculum. And also more animated videos and more interactive videos will be coming soon. And from the next class, every class will be explained in both the languages, in Telugu and also in English. Okay, my mother tongue is actually Telugu, so I prefer to say the classes in both the languages, like English and Telugu combinedly. Okay, those whoever wants to listen the classes can join. Thank you. Have a nice day.